A shaft is a rotating member used to transmit power from a driving device to a driven device. Shafts and couplings are important components in mechanical systems that transmit power and motion from one part of the system to another. A coupling, on the other hand, is used to connect two shafts together in order to transmit power and motion between them. In this response, I will elaborate on shafts and couplings in more detail. Solid shafts, these are made from a single piece of material and are used in applications where the torque and bending loads are low. Hollow shafts, these have a hollow center and are used in applications where the torque and bending loads are high. Hollow shafts are typically lighter and more efficient than solid shafts. Shafts can also be classified based on their end connections, such as keyed shafts. These have a keyway cut into the shaft, which is used to connect the shaft to a drive or driven device. Splined shafts, these have a series of ridges, called splines, cut into the shaft, which are used to connect the shaft to a drive or driven device. Threaded shafts, these have threads cut into the shaft, which are used to connect the shaft to a drive or driven device. Couplings are used to connect two shafts together in order to transmit power and motion between them. They are available in a variety of designs, such as flexible couplings. These are used to compensate for misalignment between two shafts. They allow for a certain degree of axial, radial, and angular misalignment. Rigid couplings, these are used when there is no misalignment between two shafts. They are typically used in applications where high torque and accuracy are required. Universal couplings, these are used to connect two shafts that are not aligned. They consist of two yokes connected by a cross. Gear couplings, these are used to connect two shafts that are not aligned. They consist of two hubs with external teeth and a sleeve with internal teeth. Chain couplings, these are used to connect two shafts that are not aligned. They consist of two sprockets connected by a roller chain. In summary, shafts and couplings are important components in mechanical systems that transmit power and motion from one part of the system to another. Shafts can be solid or hollow and can be classified based on their end connections. Couplings are used to connect two shafts together and are available in a variety of designs. Design equations of shaft and coupling. Design equations for shafts and couplings depend on various factors such as the material used, the type of loading, and the required performance specifications. However, here are some commonly used design equations for shafts and couplings. Torsional shear stress. The torsional shear stress, tau, is given by tau equals Tr/J, where T is the torque being transmitted, R is the radius of the shaft, and J is the polar moment of inertia of the shaft's cross-section. Bending stress. The bending stress, sigma, is given by sigma equals My/I, where M is the bending moment being applied to the shaft, Y is the distance from the neutral axis to the outermost point of the shaft, and I is the moment of inertia of the shaft's cross-section. Combined stress. The combined stress, sigma C, is given by sigma C equals SQRT sigma 2 plus 3 tau 2. This equation calculates the maximum stress due to a combination of bending and torsional loading. Deflection. The deflection, delta, of a shaft under bending is given by delta equals FL cubed, 3EI. Where F is the applied force, L is the length of the shaft, E is the modulus of elasticity of the shaft material, and I is the moment of inertia of the shaft's cross-section. Torque. The torque capacity of a coupling, Tc, is given by Tc equals Kt, d/d, tau max/2. Where Kt is a torque factor, d is the outside diameter of the coupling, d is the diameter of the shaft, and tau max is the maximum torsional shear stress in the shaft. Bending moment. The bending moment, MB, on a coupling is given by MB equals Tg/L, where T is the torque being transmitted, G is the shear modulus of the coupling material, and L is the distance between the points of application of the torque. Misalignment. The maximum allowable angular misalignment, theta, for a flexible coupling is given by theta equals Tck, 2 pi gd cubed, where K is the torsional spring rate of the coupling,